Today our lesson is on matrices. The book definition is a matrix is a rectangular array of numbers written within brackets. You represent a matrix by a capital letter and you classify it by its dimensions. And these dimensions are the horizontal rows and the number of vertical columns, and the columns are going to go up and down such as this, determine the dimensions of a matrix. Before we get started, I went back and I looked up one of the old word problems that you had from Algebra 1, preparing for the state test, to give an example of where you might use a matrix. And this was just a very basic example, just to give you that idea of where two plants were tested over a 2-week period, and they were compared using the different sunlights available, some direct, some indirect, and some no sunlight. And all the data was just placed in a matrix. And notice they're in brackets. That's what a matrix is denoted by, brackets, and by the dimensions. So this just gives you an idea of how data can be placed, and then it compares from how much they grew with plant X from direct sunlight in week 1 to direct sunlight in week 2. This is just an idea, just a basic idea of how matrices are used. So let's get started with our lesson. Again, we go back and we talk about how matrices are labeled, and they're labeled by the dimensions. First of all, they're noted by a capital letter. So here in this particular matrix, it's A. They're noted by rows and columns, rows and columns. The rows are going to go horizontal, such as this, so there are 2 rows. The columns are going to be vertical, they're going to go up and down, and so this has 3 columns. So this is a 2 by 3 matrix, and it's written like this, 2 by 3, row by column, and that's important. It has to be in that order. So the way that I always remember that, when I was a little girl, I went to the store and I bought me an RC Cola and a moon pie. And it was RC. So if you ever had an RC Cola, that will be a way to remember that it's in that order. But it's row by column. And this is going to be very, very important whenever we start to multiply. So this first part of the lesson is just really stating what the dimensions are in specific types of matrices. In this first example, A, to write the dimensions, we look at rows. So this has 3 rows. And then it has 3 columns that go up and down. So it's a 3 by 3, 3 rows by 3 column matrix right here. And it's written 3 by 3. Now because these are the same size, 3 by 3, I can have a 2 by 2, or I can have a 4 by 4. If the rows and the columns are the same, then we call this a square matrix, which makes perfect sense because it has a shape of a square. Rows by columns are the same. In B, we have 1 row, and it has 3 columns, and the columns would be 1, 2, and 3. So here are my 3 columns. And I would denote this as a 1 by 3 matrix. Because this only has 1 row, we call it a row matrix. So this is considered a row matrix because it only has 1 row. In example C, we have 4 rows. Here's my first row, second row, third, and fourth. But it only has 1 column. So this is a 4 by 1 matrix. Because it only has 1 column, we call it a column matrix. So this first flip chart here on matrices, it tells you to name it by dimensions, rows by columns. If it's the same, 2 by 2, 4 by 4, 3 by 3, it's called a square matrix. If it only has 1 row, it's called a row matrix, and only 1 column, it's called a column matrix. Just a little more practice on this. In this first example, I have 2 rows, and then I have 1, 2, 3 columns. So this is 2 rows by 3 columns, a row by column, 2 by 3 matrix. In example 2, we have 1 row, and then I have 3 columns. There's my 1, 2, 3 columns. This is a 1 by 3, and because it only has 1 row, it is considered a row matrix. Number 1, I have 3 rows, and then I have 2 columns. So 3 rows by 2 columns is a 3 by 2 matrix. And by now you should be able just to see those and to determine what they are. Again, down here, we're looking at rows by columns. We have 3 rows. And then we have 3 columns, 1, 2, and 3. And this is a 3 by 3. Because they're the same, we call this a square matrix. square matrix. Number 3, we have 3 rows and 1 column, 3 rows and 1 column, and because it only has 1 column, we call this a column matrix. Number 4, we have 1 row and 2 columns, 1 row and 2 columns. Because it only has 1 row, we call it a row matrix. So numbers 2, 3, and 4 are those special type of matrices that have their own special name. On number 5, we're just labeling what we have here. We have 2 rows and we have 3 columns. So this is a 2 by 3. And in number 6, we have 4 rows and 1 column, 4 rows and 1 column, and so this is considered a column matrix. So again, all of this was to just kind of make sure you understood the row by column and the dimensions and how they're named. In the last part of this flip chart, we're looking at the elements within the matrix. So when I read this and I refer to matrix A and B, I'm looking for that element. That's what each number or each variable in that particular matrix is called, the element. When I look at number 6 doesn't say A sub 21, it says A sub 21. Again, we're remembering that this is row by column, row by column. So this is row 2, column 1. A tells you to go to matrix A. So I go to matrix A and I look at row 2, column 1, row 2, column 1, and the intersection of those two is the element 1.5, 1.5. 7 says B sub 1, 2, row 1, column 2. On this one I only have 1 row, but I have row 1, column 2, and the intersection there is the element negative 3. So number 7 would be negative 3. The answer would be negative 3. Number 8, go back to matrix A and look at row 3, column 1. Here's row 3, column 1. The intersection there is the element 7. So that's just identifying in each matrix which element is being questioned. Then I have a little question down here that just kind of bears asking. What size matrix would it be with only 1 number? So if I had only 1 number, let's say negative 4, then this would be considered the dimensions, a 1 by 1, and because those are the same, a 1 by 1 square matrix. So from these flip charts, you should be able to recognize which element is being questioned and state the dimensions of the matrix.